So in this exercise, which is problems involving bearings, we're going to be looking at example 17. A plane leaves a town and remains on a bearing 122 degrees for 260 kilometers. So this plane started here and went towards this direction, and it's probably still flying, but it's maybe arrived at a point. This does start as a stop, maybe. And it's going at 260 kilometers at that bearing. Okay, now how far south of the town is that plane? So the town is right here, and it's asking how far is this plane, okay, south of that town. So it's asking for this particular distance. So I'm going to draw a triangle here, like that. Okay. Now, if I wanted to find out what is using trigonometry, well, I need firstly one edge that we have to know, which is 260 kilometers right there. We need to know the fact that this is a 90-degree angle because that will make this a right angle triangle. And this angle here, this missing angle, is going to be 180 subtracted by 122, and that's 58 degrees. Okay, this is bearing in mind that these two angles have to add up to be 180, so that is just 180 minus 122. Okay, so once we've got that, we need to find out what this distance is. So we'll just call this maybe x. Okay, that's what we want to find. Now, using Sakatawa, okay, and the fact that this edge here is our hypotenuse, okay, which is the longer side, whereas this edge here is just right adjacent or next to these two angles, so we call that A for adjacent. We're going to be using our tan ratio, so tan of 58 degrees, okay, if I write that properly, tan of 58 degrees is going to equal to x over 260. Now, you know that if you want to solve for x here, and it's x is divided by 260, you're going to undo that division of 260 by multiplying both sides by that 260, like that. Just so that the 260s cancel like that. So on the right side, you're left with x. On the left side, you're left with this, which is 260 tan 58, and that would be 416.08. Okay, so I'm just going to make an effort and put two numbers because the question does say to round to one decimal place. So now just by looking at that number, which is the second number after the dot, that will round this number up by 1. So I would say that x is approximately 416.1 kilometers. Okay, now we're off to B. What is the bearing of the town from the plane? So from the plane, which is right here. Okay, so this is where the plane is, okay, P for plane. We're going to find out what the bearing of the town is. So this is the town right there. So the angle that we need to find out is this angle right here. Okay, so we start from north and we go in a clockwise direction until we reach that line pointing towards the town. So how do we actually find that out? Remember, when we have two compass bearings like this, okay, it's very important that we use any alternate angles that we can find out. So here's an alternate angle that I can see. So if this is 58, and this part here is also 58. So I'm just going to draw that right in, like that. Now, if that is 58, that means this whole entire angle here has to add up to 360. So if I wanted to find out just the red bit of it, I'll just get 360, but subtracted by that angle there, which is 58. And that would be leaving me with this angle here. So let's do that. 360 minus 58. Bearing is equal to 360 degrees minus 58 degrees, which is a total of 302 degrees. Okay, so that's it for example 17. Now let's try and do just some basic questions out of the next exercise. Okay, that's present. So 8 at 7. Question 1. A yacht leaves Sydney and sails 120 kilometers on a bearing of 80 degrees. Right. So here's the yacht. Okay, it's leaving Sydney. It's traveling 120 degrees here at a bearing of 80 degrees right there. So how far north of Sydney is the yacht? So if Sydney, okay, on that same parallel line there, horizontal line, sorry, is here. From there to there, okay, is what it's asking. Okay, so it's how far north has this yacht traveled, okay, in this direction, right? So I know it's traveled this direction here, but that's a combination of easterly and north direction. So how do we actually find that? Well, we need an angle inside the triangle. So this angle here, okay, this angle is going to be 10 degrees because this 10 and that 80 degrees add up to become this 9-degree angle right there. So now if you look at this triangle, if we're trying to find out what this is, okay, let's just call this, we won't call this x because they already used x somewhere there. Okay, actually we'll call it x because I think that x is for that anyway. So this is x, right? Now if that is x, then that means x is the opposite edge, whereas 120 kilometers here is our hypotenuse, and that is opposite the 9-degree angle. So using Sakatawa, we know that O and H involves the sine ratio. So, okay, so if I have sine of this angle, which is 10 degrees, okay, I'll have this equal to the opposite, which is x, over hypotenuse, which is 120. So let's write that down. X over 120. Now, if I wanted to solve for what's x, I need to multiply this by 120 on both sides to get rid of that 120 there, so that I have x left. Okay? So if I cancel that out, then x is simply equal to this left. So 120 sine 10 is going to give us 20.837. And it doesn't say what to round to, so I'm just going to round to 1 decimal place. So this will be approximately 20.8 kilometers. Okay, that's this distance here. Okay, that's how far north the yacht has traveled to go towards this point, Y. Now, what is the bearing of Sydney from the yacht? So remember, the important word is where it's from. So I'm going to start from the yacht here. Look at that compass bearing. Okay. And from north, if I travel towards S in a clockwise direction, what angle is that? Okay, well, we know that using the angle sum of a triangle here, right, I can find out this angle. That angle there is going to be 180 subtracted by these two angles. So subtracted by 90, subtracted by 10, that's equal to 80 degrees. Now, if I get that as 8 degrees, okay, then what is this whole entire angle then? It is simply the total of 180 degrees. That's a straight angle, straight line, okay, or angle sum of straight line, sorry, plus 80 degrees, okay. So if I plus 180 with 80, that should be it. So B would be 180 plus 80 degrees, which is a total of 260 degrees. Okay, and that is the bearing of Sydney from the yacht. Okay, we'll do one more question, question 2. So Colin leaves Ningen and drives 204 kilometers to Burke. So he was here. Okay, Colin was here, and Colin was here in Ningen and drives 204 kilometers towards Burke, which is right there. So the bearing of Burke from Ningen is 323 degrees. So that angle there is 323 degrees. For part A, they want you to find the value of theta. Now theta is right here. This angle here, along with this angle, would add up to be 360 degrees. So if you wanted to find theta, you simply get 360 subtracted by this angle to get this angle remaining. So theta, in this case, okay, theta is equal to 360 minus 323 degrees. Okay, 360 minus 323 will be 37 degrees. Okay, so that's the angle that's over here. Now, for part B, how far north of Ningen is Burke? So if you look at this from this perspective, Ningen's here, Burke's here. But if I was to construct a right angle triangle like this, okay, you can see, okay, Ningen on the same horizontal line here at this point towards Burke is that vertical distance that we want to find. So we want to find how north Burke is of Ningen. Now to do that, let's see. Well, you know what? I don't have to draw that triangle. I can draw the other triangle instead. I can draw it this way instead. This might be more helpful. And I'll tell you why. It's because we've got angle theta already. Okay, if we drew the other triangle, then we need this angle, which we don't have. So theta here, we said was already 37 degrees. Just going to write that there. Whoops. Okay, so 37 degrees is right there. This is indeed a right angle triangle. And now I have to find out what this distance is. So I'll call that x maybe. All right. Now, I've got 204 kilometers here, and that is the side that is opposite the 90 degrees. That is our hypotenuse. Whereas the adjacent side here, okay, is right next to both 37 degrees here, 90 degrees. So that is just our adjacent side. So if we use Sokotawa, the correct trig ratio we're using that involves A and H is cosine ratio. So we're going to write cosine of 37 degrees, and that's equal to our adjacent edge, which is x over 204. So let's write that down. All right. So cosine of 37 degrees is equal to x over 204. And once again, I have my x on the numerator. So if I was to find x, I need to get rid of this denominator here. So I times this by 204. And I also times the left side by 204. So that these two cancel, leaving me with x equals to what this is. So 204 cosine of 37 is going to be 162.92. Once again, the question didn't say what to round to, so I'm just going to round it to one decimal place. So that will be 162.9, since this number here is under 5. Right. Our last question is, what is the bearing of Ningen from Burke? So, well, the thing is, from Burke, which is right here, if I was to travel in a clockwise direction, starting with me pointing north towards Ningen here, I need to find the sum of this angle here, as well as this green angle here. That green angle we can find by looking at that triangle right there, okay? Because in this triangle, we've already got 90 and 37 as these two angles. So if I was to subtract those two angles from 100 degrees, I will find out what this angle is left. So that angle there is simply 180 subtracted by 90 subtracted by 37. So let's do that on the calculator, and I will get 53 degrees. Okay. Now, if I was to find out what the bearing is, okay, which is this line, I'm just going to put that permanently there. Okay, that angle there is a total of 9 degrees, as well as that 53 degrees right there. So 90 plus 53 is what we're trying to find as our bearing. So we're going to say 90 plus 53, and that should equal to 143 degrees in total. Okay, and that's how you do question 2.